Okay, so now that in the previous page we have set up what a synapse looks like when it, before an action potential reaches the end of the neuron, we are now going to talk about what happens, the events that happen when that action potential does finally reach the end of the neuron. There's a couple of resources for you to look at. One, there are these images here in your homework lesson. They're also found in your book, and they take you through what happens. This is right as that action potential is reaching the end of the neuron. Okay. There's also this video here, which I highly recommend that you play and look at and see what are the events that are occurring at the synapse. And then what I will do is I will now continue with the active learning exercise to help you master this material. First, I do want to go to the notes page, and I want to go ahead and define a couple of channels. Okay, you may remember this from when we were talking about action potential, so hopefully this is something you can fill in very easily. So voltage-gated calcium channel, this is the new one. So what ions are transported through the channel? Well, the word right in front of channel gives us our key. That is calcium. Which way will the ions move? Okay, turns out they will move into the presynaptic cell, or neuron, I should say. Okay, and if it's not always open, well, it's got a gate, so it's not always open. What triggers it to open? And in this case, it's going to be voltage, and specifically arrival of action potential at axon terminal. Let's see if we can fit that all in this little box here. And we can. Okay. All right. And what triggers it to close? Well, no more action potential. Okay. All right. This one here, not applicable for our purposes. And where is it located on the neuron? Well, it is located on the axon terminals. So that is where it's located. Okay. And I should say axon terminal of the presynaptic neuron. And let's see if we can get that all in one box up there. Okay. All right, now we've seen this player before, so you should be able to fill this out. I just want to note that where is it located on a neuron? Well, what we've got is it's going to be located on the cell body or the axon hillock of the postsynaptic neuron. Okay. And this information is what you've had before. Okay, so now let's go to our active learning exercise. Okay, so here's our active learning exercise. We've set up these pieces before. Just as a reminder, this is showing the presynaptic neuron. This is showing the postsynaptic neuron. This is showing the vesicles filled with neurotransmitter. Here is the synaptic cleft, which is that gap in between the two cells. We've got our voltage-gated calcium channel in the membrane of the presynaptic neuron, chemical-gated sodium channel in the membrane of the postsynaptic neuron, calcium in high levels outside of the cell, sodium in high levels also outside of the cell. We find both of those molecules in the gap as well. Okay. So the first thing that we have happen is we have the arrival of an action potential. So this action potential is going to travel down this axon to the end of the cell. Notice we have something sensitive to voltage, and action potential is all about changing voltage. This channel will open. And when it opens, calcium will pass into the presynaptic neuron. As it does so, it causes the vesicles with neurotransmitter to fuse with the plasma membrane of this cell. And when it does, neurotransmitter leaves the vesicle and moves into the cleft. Neurotransmitter then travels across the cleft and binds to the chemical gated sodium channel. At this point, just as has happened before, the chemical gated sodium channel opens, and now we are going to let sodium come into the cell. If enough sodium comes into this cell, then enough to reach minus 60 millivolts, then we will trigger an action potential down this cell in the axon hillock area. Okay. Now you may be asking yourself, what turns this off? We don't want this neuron to be continually firing. You can imagine what would happen if we were continually saying muscles contract, if we're telling our effectors to do things. It would be chaos. So we want to turn the signal off. We want to stop the action potential. Okay, what happens? Action potential travels down to the end, and then there are no more of those voltage-gated channels we saw before to continue propagating. So action potential is gone. That allows us to close this gate, and there will be pumps that will reset the calcium outside of the cell, at least in high levels outside the cell. But we still have to get rid of this neurotransmitter. And that's where this thing comes along. I have it drawn like a Pac-Man. If you ever played the video game Pac-Man, Pac-Man would chew up things. And so that's what this molecule does. In your book, it's called acetylcholine esterase because it is going to be chewing up or hydrolyzing a very specific neurotransmitter called acetylcholine esterase. So what Pac-Man does, it'll be chewing up a very specific neurotransmitter called acetylcholine. So what Pac-Man does is it comes over here and it chews this thing up. If you turn it to the other side, it's got a lightning bolt through it, meaning that it's been split into pieces. And once it's been split into pieces, it can no longer bind to the chemical gate. So the chemical gate closes, and the pumps take sodium back out to the outside, and we don't get stimulation of another action potential. Now there's one more piece to resetting everything back to a resting state, and that is, what do you do with this broken down neurotransmitter? There's a couple of options, and they're not mutually exclusive. Many of them are happening at the same time. One option is this neurotransmitter can simply diffuse out of the cleft and be degraded by other components of the body. Another option is that the pieces can be reabsorbed into the presynaptic cell, put back together, and put back in a vesicle. And then the final option is that the cell then makes more neurotransmitter and packs it in these vesicles. And so now we're back to our resting state. And this postsynaptic cell won't fire another action potential until the events happen all over again. Okay, so my final point here would be that to please take a minute and make sure you understand each of these steps one by one of the synapse. You've got a couple of things to help you. One, here's an activity that helps you put these in order here. But also in your notes packets, I want you to make sure that you can list out the events of the synapse step by step, both saying how action potential is transferred from one cell to another, and also how you can stop transferring it. Again, as a quick recap here at the top, I just want to point out that here we have electricity traveling inside the cell. When we reach the inside of the cell, we send a chemical neurotransmitter as a type of relay messenger from one cell to another. And then we're going to trigger another set of electricity, another electrical signal in this postsynaptic cell. So a simplified version would be electricity, chemical messenger, electricity.